This is a C2H4. This is ethane. For this ethane, this is a loose structure. Alright, so there are these bonds, right? This is a double bond. After you draw this loose structure, there are double bonds here. But in a multiple bond, or whether it's a double bonds or triple bonds, there are actually two different types of bonds. One is called sigma bond. One is called pi bond. What's a sigma bond? Sigma bond results from head-to-head overlapping or head-on overlap. Okay. First of all single bonds are sigma bonds. And one of the bonds in a multiple bonds, that's always sigma bond. So you can think about the first bond, another way to put it. The first bond between two atoms must be a sigma bond. If there's only one bond, must be sigma bond. If there's a multiple bond, the first bond connecting these two atoms must be a sigma bond. You put on top or bottom, does not matter. Alright, now another bond in the multiple bond, this is called pi bond. So in this case, it's a pi bond. Alright, so let's say, again, I go back to this example we talked about in the previous slide. Now, for this is a triple bond. How many sigma bond or how many pi bonds are in this molecule? Alright, again, the first bond connecting the two atoms, this is sigma bond. Here's a sigma bond. So there's a two sigma bond, and here we have to say there is a two pi bonds. There are two pi bonds. Alright, now, so most likely, you are going to get a question, give you this formula, and ask you how many sigma bond, how many pi bond. Remember, if that's the question, you still need to draw the Lewis structure first. However, sometimes the Lewis structure is given to you, and then ask you how many sigma, how many pi. And that's quite easy, really. Now, what's this head-to-head, head-on overlap or side-on overlap look like? Alright, so, by the way, here's pi bonds are always weaker than sigma bond. I'm going to skip the bond strength for now. We're going to come back in a later chapter. Alright, so now, pi bond are weaker than sigma bond. But what's the head-on overlap and side-on overlap look like? Here, by the way, this will be how the question look like. You know, how many sigma and pi bonds in this molecule, and you firstly have to get this Lewis structure out. Now, once we got this Lewis structure, and then we can answer the question. But here, this picture here show you what the head-on overlap or the the side-on. I also like to call sigma bond as a head-to-head overlapping, or this textbook called head-on. Pi bond, some people also called shoulder-to-shoulder or body part, shoulder-to-shoulder overlapping. Alright, so this is how it looks like. This carbon here, what's the hybridization? This carbon is sp2, right? So there should be 3 sp2 hybridized orbitals. They look like, if this is carbon, they look like this, trigonal planar. And with 1 electron on each. Okay. Let me do electron here, with 1 electron over here, over each. Alright, so this electron will form a bond with this electron from hydrogen. Okay, the blue circle here, the blue sphere, this is our hydrogen's orbital. This is a 1s orbital. Because the electron is on 1s hydrogen orbital. Now they pair up. This is a bond. So this region here, let me go back here, and I want to highlight this to show you this overlapping is the same thing as here, as a bond here. That's the head-to-head overlapping. That's a sigma bond. All right, so of course it's the same thing for the rest 3 carbon-hydrogen bond. So this is the same, because this is also sp2 hybridized. Now, what about here? So here, again, this is okay. Again, this is a sp2 hybridized orbital. So this here is a sp2 hybridized orbital. This is a sp2. This is a sp2. All right, and then there's a 1 electron in this sp2, but so is the other carbon. This is exactly the same sp2, but you see here there are overlap with the head-on. And then the other one, so there is a for sp2 only use 2 p orbitals. There is 1 left. That's over here. That's a p orbital left. So this pz, that's a perpendicular to this sp2 hybridized orbital plane. All right, so we have a 1 electron here, and so is another carbon. There is a p orbital left, so there is another another electron. So they overlap, and that's what we see here. That's what we see here. So this overlapping, this is our pi orbital. You see here, this is the same thing as here.